Hello again. In this video, I'm going to go over this homework problem from 5.2. And so in this problem, it says use geometry, not Riemann sums, to evaluate the definite integral. Sketch the graph of the integrand, show the region in question, and interpret your results. Okay, so let's first sketch the graph of this integrand, where the integrand, of course, here is the square root of 49 minus x squared. So let's see if we can't figure out what the graph of this function would be without a calculator. Now, obviously, if you had a graphing calculator, you could plug it into your graphing calculator and see what it looks like, but let's try and do it without a graphing calculator. Okay, one way of recognizing what this graph looks like is you could square both sides to get rid of the square root. Now, when you square the left side, of course, you get y squared. When you square the right-hand side, the square root is going to cancel with the square. And that's just going to leave you with 49 minus x squared. Now, one thing I want to mention here is when you square both sides of an equation, there's the possibility of introducing extraneous solutions, which are essentially extra solutions that are introduced in this equation that appear in this equation but do not exist in the first equation. So we'll talk about that in a second. Now, after you square both sides, you'll end up with this sort of equation right here. And what you can do is you can just add x squared to the other side. And you may recognize this as the equation of a circle. The equation of a circle looks like this: x minus h squared plus y minus k squared equals r squared. That's the equation of a circle centered at hk with a radius of r. And so in this case, you can see that the center must be at 0, 0, and the radius is 7, because 7 squared gives you the 49 on the right-hand side. Okay, so this equation right here really describes a circle centered at 0, 0 with a radius of 7. Okay, but that's what this equation describes. Okay, that's not exactly what this equation describes. And that's because of this idea of introducing extraneous solutions. When we square both sides of this equation, there's the possibility of getting extra solutions here to appear in this equation that weren't in this equation, that weren't solutions for this equation. So let me try to explain what the difference might be between these two equations. So if you were to start with this equation, which is the equation of a circle, and you actually solve for y, right, you would subtract x squared to the other side, and then to solve for y here, you would take the square root of both sides. And when you take the square root of both sides, you actually have two possible answers here. It's either plus or minus the square root of 49 minus x squared. Okay, the reason that's the case is if I told you that y squared was equal to, say, 25, when you go to solve this and you take the square root of both sides, one possible answer is, of course, the square root of 25, which is 5. But that's not the only answer. You can also have negative 5 as an answer. So that's why we have to say plus or minus the square root of 25. And you can see that because 5 squared is 25, but negative 5 squared is also 25. So when we take the square root of both sides of this equation, we must include this plus or minus sign if we're going to include all the possible solutions to this equation. Okay, so the solution to this equation right here is actually this equation, right? Y would have to equal plus or minus the square root of 49 minus x squared. Now, having said that, that's not the same thing as the original equation that we started with. Notice the difference between the two is that this one has the extra possibility that y could equal the negative of this square root, whereas this one is simply the positive square root of 49 minus x squared. And so when we squared both sides, we actually introduced this extra solution that did not exist in the prior equation. Okay, so that's our extraneous solution. Okay, this one's extraneous. Okay, so that's the difference here. You have to be careful when you square both sides about what extra solutions you might be introducing. Okay, so once again, this equation right here describes a circle, but that's not exactly the same as this equation up here, because the equation of the circle, when you solve for the y, actually has plus or minus the square root of 49 minus x squared as its possible solutions. Okay, so this one's actually extraneous. Now, how does this help? Well, the reason this helps is because we can draw the circle, the graph of a circle, fairly easy. It's centered at 0, 0, and it has a radius of 7. So it looks something like this. Okay, where this is 7. And so that's what this equation would describe. That would be the graph of that equation. Now, the graph of this equation is the one that we really want. Okay, and so if we were to graph just that equation, it actually would look like this semicircle, the upper half of this circle. And the reason we know that is because the positive square root of 49 minus x squared is this upper piece of the circle, and then the negative square root of 49 minus x squared would be this lower piece. Okay, so this one's the upper part of the circle, and this one gives you the lower part. Okay, and then remember, our definite integral is just going from -7 to 0. Okay, so if you go back and look at the definite integral that we're trying to find, the lower limit was -7 and the upper limit was 0. And so remember, a definite integral geometrically is the net area trapped underneath the function but above the x-axis, or between the function and the x-axis, starting at this lower number and ending at this upper number. So we're talking about the area trapped between this function and the x-axis, but starting at -7 and ending at x equals 0, which is actually just this area in here, the net area in here, which happens to be just 1/4 of this circle centered at 0, 0 with a radius of r. So if we want to find this area geometrically, we could just take 1/4 of the area of this circle. And remember, the area of a circle is pi r squared. Okay, so the area of this quarter piece would just be 1/4 pi times r squared, and in this case, r is 7, because that's the radius of this circle. Okay, so this would be the area of this little quarter piece. Okay, and that just happens to be 49 over 4 times pi. Okay, so let's just go back and check that answers. Okay, so the graph would look like C. That's the graph of this definite integral, the area of this, the net area that's associated with this definite integral. And then the area, the net area that this definite integral describes is 49 pi over 4. Okay, and we found it geometrically. Okay, so I hope you found this video helpful. Again, in the future, I'll continue to work on some homework problems from Chapter 5, and hopefully you'll get a chance to look at some of those other videos. Thank you for watching. Bye-bye.